As we get older, our bodies break down. Our hair grays, our joints stiffen, our fertility declines, and our minds slow. We accept this physical decay as an inescapable law of biology, a mandatory tax on living. But across the wider tree of life, that assumption begins to look like a mammalian quirk. Ancient lineages that have shared this planet with us for hundreds of millions of years, certain reptiles, amphibians, and fish, experience the passage of time very differently. Some species of tortoises and salamanders carry traits that seem impossible by human standards. They lay just as many eggs in their later years as they do in their youth. They show almost zero signs of biological decay, and if they lose a part of their body, they can simply grow it entirely back. Mammals age with a speed and severity that stands in sharp contrast to these other lineages. Our bodies deteriorate in clear, predictable ways that many other vertebrates seem to have bypassed. Natural selection optimizes organisms to survive and pass on their genes. A process that steadily destroys the body and guarantees death directly undermines those exact goals. Evolution should have eliminated a process this destructive millions of years ago. This leaves us with a profound mystery. Why do humans, the apex predators of the modern world, run on a strict timeline of self-destruction, while lesser species hold the biological secrets to youth? Our genomes are missing the specific genetic repair mechanisms that other vertebrates have maintained for hundreds of millions of years. We lack the cellular defenses that keep the rest of the natural world resilient against the passage of time. To understand where those biological defenses went, we have to trace our lineage back to the darkest, most dangerous chapter of our genetic history. Our fragile, decaying bodies are a permanent scar left over from an era when our earliest ancestors were prisoners to prehistoric monsters. Over 100 million years ago, the Mesozoic era was an empire completely dominated by the titans of the ancient world, the dinosaurs. Early mammals were forced to the extreme margins of this environment. They were tiny, terrified insectivores, scurrying through the pitch-black shadows to survive. A peaceful death at the end of a long life was an impossibility for these creatures. Nearly every single life ended violently and quickly as a predator snack. Surviving this unrelenting nightmare at the very bottom of the food chain for over 100 million years rewired our DNA. Biologists explain this specific trauma through the longevity bottleneck hypothesis. Evolution filters out lethal early life mutations, weeding them out before reproductive age. But because early mammals were eaten young, late life decay became invisible to natural selection. Without pressure to survive to old age, harmful mutations flooded our genetic code unchecked. Any genes and genetic pathways we had to keep us healthy and fertile into old age just weren't maintained. If you're guaranteed to be eaten before you reach old age, there is zero evolutionary reward for paying that energy cost. Our early ancestors abandoned those pathways entirely. Dinosaurs also forced our ancestors to become exclusively nocturnal to avoid being hunted during the day. Hiding from the sun meant mammals lost a universal DNA repair mechanism designed to fix damage from UV radiation. The brutal environment of the Mesozoic systematically stripped mammals of the biological tools required to survive gracefully into old age. We were conditioned to live fast and die young. Roughly 66 million years ago, an asteroid impact wiped out the non-avian dinosaurs, silencing the giant predators forever. The surviving mammals finally stepped out of the dark. They rapidly diversified, growing in size and conquering a suddenly empty globe. Sometime around 65 million years ago, the pantodonts emerged. They were among the first known mammals to grow to massive sizes, reaching up to 42 kilograms in a relatively safe, predator-free world. Yet, when paleontologists analyze the fossilized bones and teeth of the pantodonts, they find a shocking biological reality. Despite their massive size and the lack of predators, they still lived incredibly fast and died young. The asteroid killed the predators, but it couldn't undo the genetic damage already etched into our DNA. The biological subjugation of the Mesozoic survived the extinction. We humans built modern civilizations and extended our lifespans with medicine, but we still carry this invisible prehistoric damage in every cell of our bodies. The aching joints, the cellular mutations causing disease, the gradual cognitive decline. These daily realities of aging are a direct, unbroken link to the terrified existence of our Mesozoic ancestors. Humans have inherited the Earth, but our bodies remain bound by the biological constraints of our first ecological enemies. You can take the mammal out of the Mesozoic, but you cannot take the Mesozoic out of the mammal. Subscribe to Ancient World Unveiled for more forgotten truths buried in time.